You have 5 apples. Your friend asks for 7. What's left? Your calculator says -2, but negative apples? That's impossible. Yet mathematics says it's perfectly fine. Today you'll discover why we invented different types of numbers, and trust me, the reason is brilliant. Each type solves a problem the previous one couldn't. Let's start from the very beginning. Ancient humans needed to count. 1 sheep, 2 sheep, 3 sheep. These are natural numbers, the numbers we use for pure counting. Simple, right? But then someone asked a tricky question. What if I have 0 sheep? Natural numbers can't represent nothing. We need a number for 0. Problem spotted. So mathematicians solved this by inventing whole numbers. Natural numbers plus 0. Now we can count. 0 sheep, 1 sheep, 2 sheep. 0 represents nothing. No sheep, 0 rupees, no pencils. Problem solved. But wait, winter arrives. The thermometer shows -5 degrees. Whole numbers can show temperatures below 0. New problem. Enter integers. We extend the number line to the left, adding negative numbers. ... -3, -2, -1, then 0, then 1, 2, 3. Now we can show temperatures below 0 like -5 degrees Celsius, bank account debt like -$200, floors below ground level like basement 2, elevations below sea level like -50 meters. Every problem we've seen? Solved. Pause here. Before I continue, answer this. You're recording temperatures for a week. Which number type do you need? Natural, whole, or integers? Think about it. 5 seconds. Got it? Integers. Because temperature can go below 0. Understanding why we need each type is more important than just memorizing name. Great job. Now here's a new problem. You and 3 friends share 2 pizzas equally. How much does each person get? Let's see. 2 divided by 4 equals... Integers can only give whole amounts. 0 pizzas? No, too small. 1 pizza? No, too much. Integers can't solve this. The answer is half a pizza, 1/2, written as 1/2. But 1/2 is not an integer. This is where rational numbers come in. Any number you can write as p divided by q, where both p and q are integers, and q is not 0. And here's a surprise. 5 is also rational, because 5 equals 5/1. Quick check. Classify these numbers. 7, 0, -3, 1/2, and -5/2. Pause and think. Which types are they? 7 seconds to think. Let's check your answers. 7 is natural, whole, integer, and rational. All 4 types. Because 7 equals 7/1. 0 is whole, integer, and rational. Not natural though. Natural numbers start at 1. -3 is integer and rational. Not natural or whole, it's negative. 1/2 is rational only. It's not a whole number. And -5/2 is also rational only, a negative fraction. Notice something cool. A number can belong to multiple types. 7 is all 4 types, because each set contains the previous one. Think of them like nested boxes. Integers contain whole numbers, which contain natural numbers. Let's see the complete picture. We started with natural numbers for counting, added whole numbers with 0, then integers with negatives, and finally rational numbers with fractions. Each time we hit a limitation, we expanded our number system. That's how mathematics grows, by solving problems. But wait, we're not done. Here's a cliffhanger. Can you write square root of 2 as a fraction? Try it. 1/1? No, that's just 1. 7/5? That's 1.4, close but not exact. Spoiler alert, you can't write square root of 2 as a fraction. It's not rational. There's a mysterious fifth type we haven't met yet, irrational numbers. In the next video, we're diving deep into rational numbers as decimal. See you there.